Problem 1, if x minus 1 over 3 equals k and k is equal to 3, what is the value of x? So what we're going to do is we're going to take the fact that k is equal to 3, substitute it in, and then solve the equation that's left over. So here we have x minus 1 over 3 equals k, which is now 3. I'm going to multiply both sides by 3 to make the denominator of 3 disappear. So here I have x minus 1 equals 9, and then if I add 1 to both sides here, x is going to be equal to 10, or answer choice D. Number 3, on a Saturday afternoon, Armand sent M text messages each hour for 5 hours. Tyrone sent P text messages each hour for 4 hours. Which of the following represents the total number of messages sent on Saturday afternoon? Well, here's what we're going to do. We're going to take the number of text messages and multiply it by the hours. Because let's say Armand sent 2 text messages each hour for 5 hours. He would have sent 2 times 5, or 10 total text messages. Well, Armand didn't send 2 messages, he sent M. M each hour for 5 hours means there are a total of 5 M messages. Same difference with Tyrone, it's going to be P times 4, or 4P. And the total means we're going to add them up. So here our answer is letter C, 5M plus 4P. Problem number 4. Kathy is a repair technician for a phone company. Each week she receives a batch of phones that need repairs. The number of phones that she has to fix at the end of each day can be approximated by this equation. So P equals 108 minus 23D. P stands for the number of phones left, and D is the number of days that she worked this week. What is the value of 108 in that equation? So we didn't want to know what this 108 represents. And it's always a good idea when you do these questions to first read your answer choices. Letter A, Kathy will complete repairs within 108 days. So letter A says 108 stands for days. Letter B, Kathy starts each week with 108 phones. So very, very different. Letter A stands for 108 days. B stands for phones. C represents the phones that are repaired at a rate of 108 per hour. D represents the phones at a rate of 108 per day. So letters C and D stand for rates per hour and per day. So what you want to do now is I choose a value for one of the variables. Let's say D is equal to 3. Now what does D represent? 3. So in this case, the days is 3. So 3 days of working. P represents the number of phones. Well, if D is 3, I'll substitute that in. P, the number of phones, equals 108 minus 23 times 3, or 108 minus 69, or 37 phones. So that means that if she works 3 days, she has 37 phones left over. So what does this 108 represent? Well, if Kathy worked no days, if D was 0, you would have 23 times 0, which is just 0. So if Kathy worked no days at the beginning of the week, when she hasn't worked yet, she starts off with 108 phones. So that's why our answer is letter B. Kathy starts each week with 108 phones. So tips for these questions is, number 1, to always read your answer choices to see what each of the numbers possibilities could be. And then start to plug in different values into the equation and interpret what those values are saying. Number 6. A pediatrician uses the model above to estimate the height of a boy in inches. So H represents the height of the boy in inches in terms of the boy's age. So H is the height, A is the age in years between 2 and 5. Based on the model, what is the estimated increase in inches of a boy's height each year? So what I'm going to do is I'm going to say, okay, well, the ages go from 2 to 5. So let's say the boy is 2 years old. So A is the age in years, so A is 2. If I plug 2 into the equation, the height is equal to 3 times A, 3 times 2, plus 28.6. And if you simplify that, that means a 2-year-old boy, his height is 34.6 inches. So when the boy's age is 2, they're 34.6 inches. Now I need to know the estimated increase of a boy's height each year. So now let's pretend the boy is 3. I'm going to plug 3 in for letter A. So the height is going to be 3 times A, which is now 3 times 3, plus 28.6. If I simplify that, that's 9 plus 28.6, or 37.6. So what is the estimated increase in height each year? To figure out the difference from 34.6 to 37.6, I can just subtract, and it looks like here the answer is 3. So letter A. So that's another question where you actually have to interpret the equation. This question could have been phrased, what is the value of 3? What does this 3 mean in the equation? And in this case, this 3 next to the A represents the estimated increase in inches of a boy's height each year. Problem 8, if A over B equals 2, what is the value of 4B over A? Well, what I can do is I can take the fact that A over B equals 2, and I can solve that equation for one of the letters. For example, if I want to get this A by itself, I can multiply both sides of the equation by B so that the B's cancel. So here I have A equals 2B. Now what does that mean? Well, I need to know the value of 4B over A. What I can do is, since I know that A is equal to 2B, I can take out this A and plug in 2B. So in this case, I have 4B over A, but A is 2B. Here the B's cancel, and I have just 4 over 2, or 2. So here your answer is letter C, 2. Number 11, which of the following numbers is not a solution of this inequality? So what I'm going to do is I'm going to go about solving this inequality, and basically you go about solving inequalities the same way you solve equations, but you want to bring the x's over to the left so it's easier to read. So here I'm going to subtract 4x on both sides. So here I have 3x minus 4x is negative 1x, minus 5 is bigger than or equal to negative 3. And now to solve for x, I'll add 5 on both sides. So I have negative 1x is bigger than or equal to, well, negative 3 plus 5 is 2. And now to solve for x, I'm going to divide both sides by negative 1. But when you deal with inequalities, anytime you multiply or divide by a negative number, here we divided by a negative 1. Anytime you multiply or divide by a negative number, you have to flip the inequality sign. So here the x's cancel, and here the negative 1's cancel, and we have x. Now bigger than or equal to becomes less than or equal to, and then 2 divided by negative 1 is negative 2. So here's the solution. X is less than or equal to negative 2. So the question asks you which of the following numbers is not a solution. So this question is asking you which of the following numbers is not less than or equal to negative 2. Which of these numbers is not less than or equal to negative 2? Well, if you want to think about negative 2 on a number line, here's where negative 3 and negative 4 would be. Here's negative 1 and 0. Less than or equal to means you have a closed circle at negative 2 going to the left. So which of these answer choices is not shaded in? In this case here, letter A, negative 1. So here our answer is letter A. Number 3, A landscaping company estimates the price of a job in dollars using this expression, 60 plus 12 NH. So this is how they estimate the price of a job in dollars. N represents the number of landscapers, and H represents the number of hours. So N is the number of landscapers, H is the number of hours the job will take using that many landscapers. Which of the following is the best interpretation of this number 12? So the first thing I do is I always read my answer choices. The question is, what does this number 12 represent? Letter A, the company charges $12 an hour. So 12 represents money. Letter B represents a minimum of 12 landscapers. So A is money for 12, B is landscapers for 12. C, the price of every job increases by $12 every hour. So again, money. And letter D, each landscaper works 12 hours per day. So they all really stand for different values. A and C both represent money. So now that I have an idea of my possibilities for my answers, I'm going to start to choose convenient values for these letters and see what the values tell me. So I'm going to choose values for these variables, and N represents the number of landscapers. I don't think my answer is going to be letter B, because letter B is saying the 12 represents landscapers, and I already know that N represents landscapers. So my gut is telling me letter B is probably not right. Let's say there are 10 landscapers, and H represents the number of hours. So again, that's why I'm kind of hesitant that D is going to be the answer, because 12 is not hours, H is hours. But let's say these 10 landscapers work 5 hours each. Well, what would the price of the job be? Well, 60 plus 12 NH, or 60 plus 12 times 10 times 5, or here the job would cost $660. So if you have 10 landscapers working 5-hour shifts, the job costs $660. Let's say these 10 landscapers, so we'll let N be equal to 10 again. Let's say they don't work 5 hours. Let's say they work 4 hours. So I'm going to let H be equal to 4. So the same 10 landscapers working 4 hours. 60 plus 12 NH now is going to be 60 plus 12. I'm assuming that there's still 10 landscapers, so N is 10. But now they're working 4-hour shifts. What would the price of the job be? Here, $540. So which of the two answer choices that remain, A or C, represents this change? Here the answer is going to be letter A. The company charges $12 per hour for each landscaper, because what we have is we have a difference of $120, right? The job, if they worked 5 hours, was $660. They only worked 4 hours, so the job is $540, so the difference is $120. So that $120, when divided by the 10 landscapers working, tells me that the company charges $12 per hour for each landscaper. For these questions, it's always a good idea to read the answer choices, choose convenient values, and see what the numbers are telling you. Problem 4, if 16 plus 4x is, so that's equals, 10 more than 14. Well, 10 more than 14 is 24. So 16 plus 4x equals 24. What is the value of 8x? Well, I can't figure out 8x until I know what x is equal to. So here I'll solve this equation by subtracting 16. So I have 4x is equal to 8. Or in this case, x is equal to 2. Well, now The question is asking me not what x is equal to, but what 8x is equal to. So that's going to be 8 times 2, or answer choice C, 16. Similar kind of question for problem 1. If 5x plus 6 equals 10, what is the value of 10x plus 3? Well, let's solve for x to figure out what it's equal to. So in this case here, we're going to subtract 6 on both sides. So we get 5x is equal to 4. Here we'll divide both sides by 5. So we have x is equal to 4/5, or if you want to go as 8/10 or 0.8, either way is okay. Well, the question doesn't ask you what is x, the question is asking you what is 10x plus 3. So let's substitute in x. I'll substitute in 4/5. 10 times x, 10 times 4/5, plus 3. Here the 5 goes into 10 2 times. So I have 2 times 4, which is 8. I have this plus 3. So 8 plus 3 gives me answer choice C, or 11. Number 3, one end of a spring is attached to a ceiling when an object of mass m kilogram, so m stands for the mass, is attached to the other end of the spring stretches to a length of L centimeters. So L is the length and m is the mass. What is m when L is 73? Well, let me take the equation. L equals 24 plus 3.5 m. I'll plug in L is 73, so I have 73 for L equals 24 plus 3.5 m. And here if I solve for m by subtracting 24, here I'm going to be left with 49 equals 3.5 m. Or if I divide both sides by 3.5, m is equal to 14, or answer choice A. Number 4, the number of states that joined the United States between 1776 and 1849 is twice the number of states that joined in between 1850 and 1900. So I'm going to go, let x be equal to the number of states that joined in between 1850 and 1900. So x is going to stand for the number of states. And then it says the states that joined between 1776 and 1849 is twice that number. So that's going to be 2x. It says if 30 states joined between 1776 and 1849. So 1776 and 1849 is 2x. So if 2x equals, in this case, 30, which of the following equations must be true? Here you go, answer choice B. 2x equals 30. So we used algebra skills to set up a let statement to go about getting our answer. Number 6, when 4 times the number x is added to 12, so really 12 plus 4x, or 4x plus 12, the result is 8, so that equals 8. What number results when 2 times x is added to 7? So this question is one of those questions where you have to solve for x, and then it says, what is 2 times x added to 7? So let's try to solve for x in this first equation. We'll subtract 12 on both sides. So 4x equals 8 minus 12 is negative 4. Here we'll divide both sides by 4 to get x is equal to negative 1. Notice that's one of the answer choices, but that's not what the answer to the question is. The question doesn't want to know what x is. The question wants to know what 2x plus 7 is. So here we're going to go 2 times x, 2 times negative 1 plus 7, or negative 2 plus 7, or 5, or answer choice B. Problem 2, if 3r equals 18. So since 3r equals 18, if I divide both sides by 3, r is equal to 6. Notice that's one of the answer choices, but not correct. What is the value of 6r plus 3? So since r is equal to 6, we'll go 6 times 6 plus 3, or 36 plus 3, or 39, or answer choice letter D. Number 8, the average number of students per classroom. So the average number of students per classroom at Central High School from 2000 to 2010 can be modeled by this equation. Y equals 0.56x plus 27.2. X represents the number of years since 2000. So for example, if X is 2, that represents 2 years since the year 2000, or it would represent the year 2002. So if X represents the number of years since 2000, Y represents the average number of students per classroom. Which of the following best describes the meaning of 0.56 in this equation? So we want to know what this 0.56 is. So once again, I'm going to read my answer choices to get an idea of the direction of the question. Does 0.56 represent the total number of students at the school in 2000? So this represents total number of students. I'm already hesitant because how can 0.56 represent the number of students? Like you can't have a half of a student. So that's probably not right. Letter B, the average number of students per classroom in 2000. Again, how can you average 0.56 students per classroom? So that's most likely not right as well. Letter C represents the estimated increase in the average number of students per classroom each year. That could make sense. Each year there's an average of a half of a student more, so every 2 years there's 1 student more, so that could possibly be correct. Or D, the estimated difference between the average number of students per classroom in 2010 and 2000. So I can actually check letters C and D to see which of the two is correct. For example, letter D, the estimated difference between the average number of students per classroom in 2010 and in 2000. So I can figure out how many students per classroom there were in 2010, right? Because it says X represents the number of years since 2000. Well, 2010 is 10 years since the year 2000. So I can plug in X is 10 and figure out what Y is. That's going to be 0.56 times 10 plus 27.2. So Y is equal to 0.56 times 10, or 5.6, plus 27.2, or 32.8. So in the year 2010, there were almost 33 students, 32.8 students per classroom on average. Figure out how many students per classroom there were in the year 2000. Well, what is X going to be? I know in the year 2010, X is 10. Well, the year 2000, the number of years since 2000 would be 0. So if I plug in 0 for X, if I have 0.56 times 0 plus 27.2, well, 0.56 times 0 is just 0. So that means that in the year 2000, there were on average 27.2 students. So in the year 2000, the average number of students per classroom was 27.2. In the year 2010, the number of students per classroom was 32.8. Now, which of these two answers the question? Letter C, the estimated increase in the average number of students per classroom per year. Well, what is the difference between these two numbers? 32.8 minus 27.2 is going to be 5.6. So over the 10 years, the average number of students increased to 5.6. But this is a 10-year difference. So each year, there's a 0.56 increase. See, letter C, I think, is going to be the answer. Letter D, the estimated difference between the average number of students per classroom in 2010 and in 2000s. See, letter D is actually this 5.6 number. The estimated difference, that's why we subtracted, between the average number of students in 2010, that was 32.8, and the year 2000, 27.2. So letter D is actually 5.6. So that's not correct. Here our answer is letter C, the estimated increase in the average number of students per classroom each year.